So now that we've gone through labeling rational and irrational, let's get back to the square roots and work on those some more. So square roots, we can reduce down, and we don't want to have a perfect square left inside, basically. That's kind of what I've got written up here. And also just kind of like some grammar things, we cannot leave an answer where the denominator is a square root. We say that's not simplified. Just like in English, you've got rules about double negatives and things like that. This is one of our grammar rules. We cannot have square roots left in denominators. So we're going to be working on getting rid of those out of the denominator and also reducing our square roots down so we don't have any perfect square factors. So we're going to be using two rules. The product rule, I think it's a little bit easiest to see in our example here. I can split the square roots up. So 36 can be, I can think about it being 12 times 6. Or sorry, 36 is 12 times 3. I saw the answer there in my head. I can think about 36 being 12 times 3, so I can split it up into two square roots. You could also split it up into 4 times 9 as well. So you can tear apart square roots, and we can also put them back together. And we can see some of that. So these go both ways. You can combine two square roots together, or you can tear it into separate square roots. And the same is true down here with fractions. We can go either way. Sometimes we might want to go one way or another. But if I've got two square roots on the top and bottom, numerator and denominator, I can turn it into one. That's what I did in the last video. Or if I have one square root and it makes more sense to tear it into two in the numerator and denominator, I can use that as well. So we're going to be using both of these rules on the next page to simplify these square roots. So I've got a whole bunch here for us to do. Now there are kind of two ways to think about the ones that are not fractions. So I will show you both ways. My first way is to make a factor tree. And we use factor trees a lot, so you probably remember them from back in elementary and middle school. But I'm going to make a factor tree for 32. So I can think of anything that multiplies together to give me 32. Don't use 1 and 32, but anything else. I did 2 and 16. You also can do 4 and 8. 2 is a prime number. We've talked about those prime numbers. We've made those those factor trees before. 16, I'm going to separate into 4 and 4, and I'm just going to keep making that factor tree. Now, square roots have to do with pairs. I remember that because thinking back, I know it's algebra and people don't like when I'm right. This is x squared. Square means 2. It means pairs of things. So I'm going to pair off these 2's. So here's a pair of 2. I'm going to write it one time. Here's a pair of 2's. I'm going to write it again. And then I have 1 2 that didn't have a pair. So I'm going to put it back in the square root. Now I have a silly story that goes with this. I know it's silly, but silly things usually stick in people's minds because it's so ridiculous. So my story is, imagine doing your laundry and you're left with a whole bunch of socks. Well, you want to pair them up. So maybe you put your 2 red socks here together. Once you have your socks, you fold them over. You don't leave them loose in your drawer so they have to dig for them. You fold them over so you end up with just one pair. So that's why I wrote it one time. I would do the same thing for my green socks. I would take them, I would fold them up. I would have one pair. Then I have this one leftover sock. Who knows where its partner is? Under the bed, in the laundry chute, who knows? But it gets thrown back in the laundry basket, which is my square root symbol, and going to be saved for later, which in our case is just going to sit there. Just like we saw with our prime factorization, we're always going to be multiplying these together. So my answer is 4 square roots of 2. So that's one way to do it. Honestly, that's my preferred method because since we already have to know prime factorization, those factor trees. But if we want to use the product rule that we saw on the last page, we can split the square root of 32 up. We have to know our perfect squares. So we have to know that the perfect 2 squared is 4, then 9, then 16. Right, we got to know these perfect squares here. So 32, I could rewrite as the square root of 2 times the square root of 16 because 32 is 2 times 16. The square root of 2 is just 2. The square root of 16 is 4. So I get the same answer. Both ways work every single time. If you're going to use that product rule, the second way I did, you do need to break it down into perfect squares. So you wouldn't want to use, I guess you could use the 4 times 8, but then you would have to break 8 down again. So it might have been a little bit longer. All right, so what I want you guys to do is to hit pause. I know they're a little out of order here, but see if you can try B and D here. So try B and D, give those a go. I'll write the answers up, that way you know if you got them while you're working. You don't have to wait for the whole video to go through on this one. So make sure you can get those. Once you've tried them, then come back, watch the video, so I can walk through them. So go ahead and hit pause. All right, coming back from the pause, I'm going to make my factor tree. If you want to use that product rule instead of making the factor tree, you're more than welcome to. I chose a kind of wonky one. I did 2 times 75 instead of maybe 15 times 10. It doesn't matter. We're going to get the same answer every single time. Doesn't matter what we start with. My socks need to look the same, so I'm going to put a 5. I don't have a 2 or a 3 to go with them, and the socks have to be the same. I don't want to put a brown sock with a black sock. I'm going to throw them back in there, and we, like I said before, we're always going to be multiplying every single time. We did it with prime factorization, and we're going to do it with these reducing square roots again. Like I said, you're more than welcome to use the product. It would have been 25 times 6 is what you should have broken that down into. Let's look at D. Oops. Erase that line there. 180. I'll do the 18 times 10 this time. All right, I'm going to get my pairs. They've got to be exactly the same. They're twins. So 3. I've got a pair of 2s. And I've got this 5 that's left over. So I've got 6 square roots of 5. Again, you could have broken 180 down. It should have been 36 times 5 is how you'd broke it down with the product rule, that second way I showed you.